Hi everyone. Welcome back to Chapter 3 of our course, Introduction to Computer-Aided Design. We are now moving into Part 2 of this chapter, where we will focus on understanding the SolidWorks interface and how to navigate within it. By the end of this part, students should be able to identify and utilize key elements of the SolidWorks user interface, including the FeatureManager Design Tree, Command Manager, and mouse gestures, to navigate the workspace and perform basic modeling operations efficiently. Before we jump into the SolidWorks interface, it is important to understand some basic terminology that you will encounter frequently. These are fundamental building blocks in 3D modeling. First, we have plane. Think of a plane as a flat, invisible, two-dimensional surface. It's essentially a flat sheet that extends infinitely in all directions. In SolidWorks, you will use planes as the canvas for your 2D sketches. For example, when you want to draw the base of a table, you'd start by sketching it on a horizontal plane. Planes can also be used for creating section views of a model, like cutting a part in half to see its internal structure. Second, we have axis. An axis is a straight line, like an imaginary skewer, that can be used to create or position model geometry, features, or patterns. For example, if you want to create a cylindrical object, you'd revolve a 2D sketch around an axis. Axis can be generated in various ways, such as by intersecting two planes. Next, we have origin. The origin is the fundamental starting point in your 3D modeling space. It's the precise point where the three default reference planes, which are front, top, and right planes, intersect. Its coordinates are x equals 0, y equals 0, and z equals 0. It serves as an anchor for your design and is often used as a reference point for dimensions. Continuing with our basic terminology, we have vertex, which is simply a corner. It's the point where two or more edges meet. Imagine the sharp corner of a cube. That's a vertex. Next is edge. An edge is the boundary line of a face. It's where two faces of a 3D object meet. Edges can be either straight like the side of a square or curved like the rim of a cylinder. We also have face. A face is the surface or skin of a part. It's the outer visible area of a 3D object. Like edges, faces can be flat, such as the top of a table, or curved like the surface of a sphere. Let's wrap up this section by discussing two essential terms that you will use frequently in SolidWorks: sketch and feature. These two concepts form the backbone of how 3D models are created in the software, and understanding them is key to mastering the design process. A sketch is essentially a 2D drawing. It's created on a flat surface or plane, such as the front, top, or right plane, and serves as the starting point for most 3D features. Think of it like drawing the outline or blueprint of a shape on a piece of paper before turning it into something three-dimensional. For example, if you want to make a round hole in a block, you would start by sketching a 2D circle at the desired location. Once your sketch is complete, you use it to create a feature, a 3D element that adds or removes material. Features are the building blocks of your final part. For instance, you could take the sketch circle and use the extrude feature to push it into a solid cylinder, or use the cut feature to turn it into a hole that goes through a block. Other features like revolve, fillet, and chamfer allow you to create rounded shapes, smooth edges, or angled transitions. In short, you start with a 2D sketch and then use a feature to turn it into a 3D part. Together, sketches and features are what transform your ideas into fully defined digital models in SolidWorks. Now that we've covered the basic terminology, let's explore the SolidWorks user interface. The SolidWorks interface is designed to be very user-friendly and efficient, integrating all the tools you need for sketching, 3D modeling, simulation, and creating drawings into one cohesive workspace. Understanding the layout and function of each component on the screen is essential for navigating the software smoothly, especially when you're just starting out. This is the SolidWorks main interface. At the very top of the interface, you'll find the menu bar. This contains drop-down menus such as File, Edit, View, Insert, and more. These menus provide access to nearly all of SolidWorks' tools and functions, from opening and saving files to advanced options for customizing your modeling environment. Just beneath the menu bar is the Command Manager, which is one of the most frequently used areas in SolidWorks. The Command Manager contains context-sensitive toolbars that change based on the type of document you're working on, whether it's a part, assembly, or drawing. For example, if you're editing a part, you'll see tools for sketching and features like extrude and fillet. This layout helps keep your most relevant tools easily accessible. To the left side of your screen is the FeatureManager Design Tree. This is a chronological list that shows every element used to build your model, including sketches, features like extrude or cut, reference geometries, and more. It's essentially the design history of your part or assembly and allows you to edit or reorder features with ease. To the right side of the interface is the task pane. This vertical panel includes various tabs such as the Design Library, File Explorer, and View Palette. The task pane is especially useful for inserting commonly used parts, managing design projects, or accessing resources like SolidWorks tutorials or materials. In the main central area is the graphic area, which displays your active 3D model. This is your primary workspace when creating and editing individual parts. You can sketch, apply features, rotate, zoom, and manipulate the model directly within this window. Floating near the top of the document window is the Heads-Up View toolbar. This on-screen toolbar provides quick access to frequently used display tools, such as zoom, pan, rotate, section view, and display styles, without needing to navigate menus. It improves visualization and makes navigating 3D models more intuitive. Running along the very bottom of the interface is the status bar. This bar displays real-time information such as system messages, the units being used, and what type of file or feature you're currently editing. It's a helpful reference point, especially when you want to confirm selections or keep track of your workflow status. Let's now continue exploring the SolidWorks interface by focusing on a critical section located on the left-hand side of the screen, the vertical tabbed area that includes several key managers. These tabs allow you to control and organize different aspects of your design, each serving a specific purpose in the modeling process. First and most commonly used is the FeatureManager Design Tree tab. This is essentially the timeline and backbone of your part or assembly. Every time you create a sketch, add a feature, apply a material, or insert a component, it gets listed here in chronological order. The tree allows you to view and manage the entire structure of your model. You can expand or collapse items to see sketches and features beneath them, rename features for clarity, suppress features to temporarily remove them, and even reorder them if needed. It's an incredibly powerful tool that gives you control over the history and organization of your model. Next, we have the Property Manager. This tab automatically appears whenever you select a tool or a feature that requires input, such as when you're extruding a sketch, applying a fillet, or adding a mate in an assembly. It shows the specific options, dimensions, and parameters for that operation. For example, if you're using the extrude command, the Property Manager will allow you to set the depth, direction, and whether it adds or removes material. This makes the modeling process interactive and intuitive, as the options change depending on what you're working on. The Configuration Manager is the third tab and becomes important when you're working with multiple versions of a part or assembly in a single file. It displays all the available configurations and allows you to switch between them, create new ones, or manage design variations efficiently. If you're working on a product that comes in several sizes or with different features, like a chair with and without armrests, the Configuration Manager is where you handle all of that. Another useful tab is the Dim Expert Manager, which is primarily used for applying and managing dimensions and tolerances in a model, especially when preparing for model-based definition or manufacturing without 2D drawings. It helps you add geometric dimensioning and tolerancing directly to your 3D models. This is becoming increasingly important in industries that are moving toward fully digital manufacturing workflows. Finally, we have the Display Manager, which controls how your model looks visually. It is where you can manage appearances such as colors, textures, and materials, decals like logos or labels, and scene settings for rendering. This is especially helpful when preparing your model for realistic presentations or when you want to differentiate parts by color in assemblies. To wrap up this section, let's talk about one of the most practical and time-saving aspects of using SolidWorks effectively: mastering mouse gestures and controls. Your mouse isn't just a tool for pointing and clicking. It's your main interface for navigating the 3D workspace and interacting fluidly with your model. Knowing how to use the mouse well can significantly boost your productivity. Let's begin with the left mouse button. This is your primary tool for selection. You'll use it to select items from menus, pick features in the FeatureManager Design Tree, and choose sketch entities, faces, edges, or entire components directly from the graphics area. You also activate most commands and tools with the left mouse click. It's the most straightforward but essential part of interacting with SolidWorks. Next, we have the middle mouse button, which is usually the scroll wheel on a standard mouse. This button is incredibly powerful for navigating your design. If you click and drag with the middle mouse button, you can freely rotate your model in 3D space, a crucial action for inspecting your design from different angles. Scrolling the wheel forward will zoom in, while scrolling it backward will zoom out. This helps you quickly focus on areas of interest or get an overview of your entire model. There's also a handy trick with the middle button. If you hold down the Control key on your keyboard, and at the same time click and drag the middle mouse button, you can pan your model, meaning you can move it across your screen horizontally or vertically without rotating or zooming. This is especially useful when you're zoomed in and want to examine a different part of your model without changing your view angle. Lastly, the right mouse button opens up a context-sensitive shortcut menu. This means the options that appear depend on what you've clicked on. For example, if you right-click on a face, you might see options for creating a sketch or adding a feature. If you're in the middle of a command, the menu might offer quick settings related to that tool. This dynamic menu allows you to access frequently used commands without needing to return to the command manager or main toolbar, making your workflow more efficient. Unlike the standard use of mouse buttons we discussed earlier, mouse gestures allow you to trigger commands instantly with a simple movement. Here's how it works. When you're in the graphics area, just right-click and drag your mouse in a direction. This brings up a circular guide like what you see on the screen. Each segment of this guide is mapped to a different command. The number of available directions can be customized. In this example, we're using the 8-gesture layout, which gives you access to 8 commands in a single motion. The gesture guide adapts depending on where you are in the software. On the left is the Sketch Environment Guide, and on the right is the Drawing Environment Guide. Each has its own set of frequently used tools, making your design process more fluid. As you right-drag, the guide highlights the command in that direction, giving you visual confirmation before the action is triggered. This helps reduce misclicks and keeps your workflow efficient and precise. Mouse gestures are all about reducing clicks and movement, keeping your focus on the design, not the interface. Once you get used to them, they become a natural part of how you interact with the model. That brings us to the end of this chapter. We have explored the structure of SolidWorks, the philosophy behind its modeling approach, key design intent tools, and now how to navigate and work smarter with mouse gestures. In the next chapter, we will start putting these concepts into practice,